All right, so again, welcome everybody. Today we are in part one of our kind of overall series on research statistics with ARM. So today we will be covering data confirmation, kind of a in-between step, I guess. I've kind of coined really to just talk about preparing and looking at the data as it's entered before we start really talking too statistically. So before we really think about the analysis and what's going to go on there, we have a couple things we should think about. So that's the goal of today's session. So I've got some slides, and we'll kind of actually use this presentation throughout the next three sessions. So today we're just kind of getting the tip of the iceberg here to really introduce things, and then we'll rely on this a little more heavily in the future sessions. Spend a lot of time in ARM today. All right, so starting at the really big basics here. The goal of research is often to determine whether your treatments of interest perform differently or if they are the same. The choice of treatments can be different products, different formulations, different rates of application. But what we want to know is if those treatments can be distinguished from one another in their effectiveness, in their safety to the crop, or maybe the cost. You might even be hoping that the performance is indistinguishable if your product is cheaper. So research trials are then performed so we can obtain observations of the treatment performance. And so those in ARM, we usually call those assessments, showing up as an assessment column, or ratings. We'll call them ratings as well. But then the question is, are the observed differences that we see in those assessments due to the differences in the treatments themselves, or just by random chance? And so that's really where we start to utilize statistics. And we'll kind of get to dive into that next week with the analysis of variance. But as I said, we don't want to just dive right into the stats and start running a report to see what we got. It's important to really take a look at the data that's been recorded. And so, as I said, kind of coining the data confirmation term. I don't know if it's a standard term out there, but really want to give a name to this process because I think it matters just as much as quote unquote data review, where you're talking statistics. So the goal is to catch outliers, any issues with the assessment, with the data we've recorded, to make sure that it's accurate before we really actually start thinking about the analysis. So the best way to achieve this accuracy would be to review the assessment immediately after it's been taken. If you can do that still at the trial site, then that really maximizes your options and things you can do. So today we'll kind of show processes to find any irregular values, anything that doesn't quite make sense, that really sticks out in the data that we've recorded. If you're still at the trial site, then those irregular values can be investigated and resolved. If we just jotted everything down on a piece of paper and we wait and input it back in the office, or we stick it in a notebook and we enter it the next rainy day, which might be a week or two from now, then you're really limited in the actions you can take if and when you find something unusual that doesn't seem quite right. And really at that point, about the only thing you can do is toss out something that doesn't quite make sense. And so now you're losing statistical power when we start throwing out data. So that's kind of a long-winded way to have a little infomercial, I guess, advertisement for the purpose of some of the data collection tools that GDM offers to do all of this that we're doing today when you're still at the site, to give you the maximum amount of options if and when something unusual is there. So, the issues that we might find when we're looking at the information could just be a typo of however the data was entered, or it could be an outlier, an observation that's really outside the normal or expected distribution of the data. Doesn't necessarily mean that we need to throw it away. Unusual data does not necessarily mean it's not usable. So, these extreme values, we shouldn't just throw out without thinking about them. And we'll kind of deal with that balance here when we're in ARM as well. Another tip, just thinking about ways to really tackle this accuracy would actually be before taking the assessment to really identify what is an acceptable range of values to be taking. So that way, when you're doing the note taking, those extreme values would really pop out and really maybe cut down on any surprises at the end when we're looking at the numbers. So that's really the rundown of today. As I said, kind of a short amount of slides here to set things up. We'll toggle now over into ARM and just kind of show some of the different tools and functions that will help us with this data confirmation. So I've got a trial open here. It's just an example set up to have a little bit of data to review. So I've got one assessment that's starting to get old that just disease coverage on the leaves of the plant, just kind of giving a rough estimate of the percent of area that our disease is covering the crop, our plants out in our plot, wherever that may be. And so I've just got a bunch of data points here that, however we may have obtained them and entered them, we now have them entered into the software, and we can really take a look and get a good grasp of how we feel about this assessment and its accuracy. So I guess we'll just kind of go in timeline order, maybe of the best things to do, and maybe in the order that at least I would do them if I were doing the research. I guess the first thing would be kind of before the assessment. We just talked about that acceptable range of outcomes. And there's kind of a couple things to look at in ARM for that. Of course, we could start with the rating description of what we're doing. And this is a percent area. So that's a proportion you would imagine then that, logically speaking, it would be between 0 and 100. We really can't have more of the leaf than it actually exists can be covered in disease. So 0 to 100 would be pretty reasonable. Some of the units in our list here, there actually is a minimum. I'll expand these columns out just to see there is a minimum and a maximum value. So if we're doing like a rating scale, maybe we're doing a 0 to 5 rating scale or something like that, then there's a minimum and a maximum that are really kind of hard coded for ARM to recognize. So if we're doing data entry with something like that has these defined guide bars basically for us, then if I were to type in a 7 on accident, ARM would immediately pop up and warn me and say, hey, that number doesn't make sense because it can only be a 0 to 5. So there's some things in the data collection tools that will kind of help make sure that we don't get all the way to the end and have some really extreme value, just depending on, again, the type of unit. Of course, sometimes you don't have those, but if they logically make sense with your unit, that there's some limit, you've got the minimum and maximum there for that. So that would be just like we said, kind of starting out before you take the notes. That might be helpful just to get that gauge. So that way, as you go through the numbers, kind of makes sense, and something that is a little unexpected would stand out even just as the notes are being taken. I guess, so starting out on kind of taking a look at the data, maybe the very first thing, if we're thinking about going through all the assessments that we've taken, is to decide if this assessment even is realistic or viable for us to analyze in the first place. Because all these other steps of taking a look at the data would be kind of irrelevant if we're never going to summarize this data anyway. So, something kind of depends on the experiment at hand and whether the assessment or the situation around the assessment is kind of part of the target, the goal. One example maybe is the pest infestation level, high enough to even matter. So, maybe we'd look at the untreated check. I maybe sort by the treatment number here if my check is treatment number 1, just to get a real quick sense of the pest pressure present at this time. Really, if the untreated check didn't have any pressure, are we going to be able to make any conclusions about the products that we applied if there wasn't any pest to control anyway in this example? So that can be a good first step. We have in the pest section, there is a field called acceptance level. So that would also kind of tie into this, where you can put in the numeric reference of kind of just what the grower acceptance level is, what would be a typical level of infestation that you would expect. And if we're a lot lower than that, we probably can skip over this assessment. We're not going to end up summarizing this particular assessment. It's not going to tell us much. So if that is the case, there's kind of a couple of things we can do to mark that down, so that way we don't waste time on this column later. Going down to the ARM action codes field, and that's in the miscellaneous group. There's a section of action codes. There's a long list here, so I'll scroll a little bit. There is a section here that we can identify non-analyzable data. So this is a way to denote that maybe this column shouldn't be summarized. And there's a few different options here. I guess in our case about not summarizing the data, the ES code basically just drops that column from any summary report. So if you're doing the assessment data summary, that just shows the data points on the mean. If you're doing the AOV means table, where we actually are doing the ANOVA analysis, this column, if you put the ES in a column, that will just never print in any of those types of reports. So basically, there is no point in any sort of analysis whatsoever for this column. There's some other options if maybe we do want the column to be visible, but maybe we don't need statistics. So N is kind of handy if maybe you only have data in one replicate, or if it's like a university study that only gave you treatment means and didn't have the replicated information, then you can just drop the information in the first replicate. And of course, there's no analysis that can be done. So you can mark that as an N. NM would still print the treatment means on the report, but just not analyze anything. So no statistics. So those would be some options for really marking down that this column, this assessment, really should not be statistically looked at. One other option we have for that that's pretty new is this field called data reliability. And so there's just a simple 1, 2, 3 coding that really is a yes or a no. Is this data reliable or not? So the 2 would say this is reliable, you can use this data. And then number 1 would be no, it is not. So you should not use this column for any assessments. You can mark it as a 1. And if it can be, there's absolutely nothing wrong with it. It can be at 2. And then the 3, this best, is really, maybe I have a bunch of assessments that are similar. Maybe it's a repeated assessment as we went. And this would be the best one. If you can only summarize one column from this trial, this, or maybe from that set of assessments, this would be the one to do. And we have some shortcut buttons, actually. So if you hover over the column heading here by the data, you'll see these new little icons, and they correspond with this data reliability. So we have the red X to say, no, don't use this. We have the green check mark to say that is good, you can use it, everything is just fine. And then there's that star, that's the best. Of these repeated assessments, this one's the best one to look at. It's most indicative of what happened here in this study. And you can just click that same selection again to clear that off. You can see as I'm making that selection, the data reliability field is updated. Even if you have it hidden, even, that'll still be there, so you can change that designation as you need. Oh, I didn't hide that description either. There we go. It's all gone, but it can still change. So in a really quick look, so far, I think we're feeling okay. This assessment certainly had enough pressure to seem reasonable, and so far we haven't found any issues. Obviously, as we get through some of our other tools, we could always come back and tweak this, but let's leave it as so far we've passed the few tests that we've run across so far. Okay, so now on to really the tools for performing the confirmation, really looking at what we have here in this assessment. So over on the right, on my properties panel, and if you don't have that visible by default, it may be really to the right on the far side here. And we're looking at just the properties panel here. And then I'll press the pin to kind of keep that here visible for us. Part of the way down, we have a section called Tools. And I'm actually going to work bottoms up on this list here. And I want to start with the assessment map. I kind of consider this one of the best kept secrets. It's kind of stashed away here, but it's really pretty powerful, especially here for taking a look at the data. So the assessment map is really our trial map drawn out on the screen for us, but instead of coloring by our treatment number or the replicates we've set up, the coloring system is a heat map of the assessment values that we have taken in this column. So here we're doing assessment number 1, and we have the smallest assessment value is in this very light green, and then just a gradient all the way up to the very darkest color, which would be the highest value in the assessment. So what this does is of course, give us a visual on the assessment and where high values and where low values occurred. And we can get a lot of different information from this. A really great spatial overview that just a list of numbers on a screen really can't provide. So I guess one of the first things is anything standing out to us visually. And for me, there's really not a whole lot going on over here. Because there's this one really dark plot 904. That's really a great first start would be to look at anything that's really dark compared to everything else or really light compared to everything else. That would be an extreme value that would be worth taking a look at. So plot 904, let's just close the assessment map here and go find that. I'm going to sort by plot number again to make it a little easier to find. So plot 904, here I have a value of 120. So we've kind of identified maybe a potential outlier here, a really, really large value compared to about anything else that was taken. Well, for starters, our assessment was a percent area. So actually, I know right offhand that 120 is not physically possible. So this can't really be 120. So the question is, well, what is it? I suppose it could be 20, and I just fat fingered when I typed it in. Or, well, maybe it could be 10. Technically could be 12, although everything I think we're estimating kind of in sets of 5, so probably not 12. But here's where we'll kind of cycle back to the time at which we're looking at the data. If we're looking at this a week after the fact, or even just the night of when we're back at the hotel or wherever we're at, there's really nothing much we can do. We could take a guess, but that would not be responsible of us to guess what the number should be. So in that situation, really the best thing we can do is not count this assessment. We need to throw out this 120. So over here on the right, on the properties panel, if I need to throw out a value, I've clicked into that cell, and then on the right, there is a damaged checkbox here. And so what that will do, if I just click away, you can see there'll be a red strike through. So we are crossing out that 120. So we can still keep the value that we've recorded as proof that we did take the assessment. But any sort of analysis that ARM does on this column, it will treat this 120 as if it was a missing data point, as if the cell was empty. So that, obviously we don't want the 120 included because it's physically not possible. So we really need to throw it out. The downside is we're going to lose degrees of freedom in our analysis, and so we're not going to have quite as much power in our statistics, but that is what it is. On the flip side, though, if we are looking at this data and we're still at the trial site, we have an immense advantage because we don't have to just throw this out. We can walk back over to plot 904 and perform the assessment again. We can confirm what the number should be. So that would make us feel very much better that we can go over and say, yes, actually, it's a 20. I just typed it in wrong. But again, can't do that if we've already gone. But really, if we're using some data review while we're in the field, whether it's with the ARM, you can take ARM out on a tablet with the tablet data collector, or if you're using the ARM mobile app, that also has the heat map in it to find these issues. We can have a lot more options to us to actually go and fix this value. Okay, so we've adjusted that. And now if we return to our assessment map, we've kind of corrected that value. And actually it's starting to show us a little bit more here. Now that we've got rid of that extreme value, kind of pulling everything out, we kind of have a little bit more intriguing map here, I think. Still a fair number of small values, but kind of one value that's still a little bit large. So that 203 is somewhat interesting. One thing I can do, if I click on plot 203, it's going to color by current treatment. So now it has whited out anything else except for where my treatment number 5 is in the different replicates. So this is a great way to see the consistency of that treatment across the different replicates. And in my case, since I'm kind of really looking at this high dark value here, it's definitely not that treatment 5 was just kind of high, but it really, in this replicate here, it is abnormally high compared to anything else. But just to show this color by current treatment, I kind of like to just click through the first replicate and get a glimpse of each and every treatment and how consistent it was. So looking at treatment 3, and then just clicking on the next plot will highlight whatever treatment number is linked to that. So there's our untreated check, I believe. Then treatment 4 and treatment 2, a little bit more variable. The rest of them are somewhat consistent, but that one's got a little bit different. And then there's, again, that treatment 5 issue there. So that's the color by current treatment. And I think if I just click on that, click on this box here to turn that off, I'm back to seeing the whole map. And this is the trial map. So if I go over to the options, we have kind of the same tools that we have available to us when we're just looking at our general randomization. And I think the most useful one perhaps is the true scale. So if I toggle that on, we end up zooming out just a little bit, but ARM then draws the plots according to the width and the height entered in this study. So this actually would give a more realistic spatial view of what is going on. Instead of just the little squares and kind of looking at the numbers, now we can kind of get a sense of if there's any site effect. Is there some corner of this map that's really high or really low? Is there a stripe right down the middle that, oh, well, there was some irrigation leak or something went wrong in the area of that field that we didn't pick up on until we can kind of see the overview here. So a lot of power. You can catch a lot of things that would maybe otherwise kind of go unnoticed. Just by being able to really visualize the numbers here and what we took. All right, so that is the assessment map. Again, kind of a pretty good kept secret. So it's really only found here on that properties panel, that button right there for the assessment map. And if we had multiple assessments, right now I've only got the one column, but if we had multiple, then there is a button in the corner here to go to the next column and previous column. Obviously right now it's totally empty, so there's not much to see, but you could even kind of scroll through several different assessments fairly quickly. It'll just update the map for that other assessment that you took. All right, the next tool that we have available to us is actually just right above the assessment map, and it is a Box-Whisker graph. So again, if I click on that button, it will create this graph for the column that I was clicked into. So the Box-Whisker, I guess a few just definitions, if you're not familiar with the Box-Whisker. We are graphing each treatment separately here on this graph. And our box here is the 25th and 75th percentile of the data range. In this case, it's of the different values for treatment 2. And then the whiskers, the straight lines that extend from the box, go out to any other assessment values that are in the data set outside of the 25th and 75th percentile, assuming that they're not outliers. So treatment 3, the whisker only extends out to this assessment value here, but there's one more way up here that is an outlier. And so that is marked here, and you can see when I hover, you can actually see that's plot 705. So the Box-Whisker, the calculation for an outlier, so how it decides if an assessment value is an outlier, you would take the height of the box times 1.5. And if you're that far away from the median, I believe, then you would become or be considered an outlier value. So that's really the, kind of how we are constructing this graph. Within the box, there are two different lines. I've turned on the option. The main one with the Box-Whisker is the median is the solid line, and then the dashed line is the mean. So the significance, especially here kind of with this visualization of, well, what's, if they're not quite lined up to the same spot, that can kind of tell us a little bit about the distribution of the data, whether it's skewed one way or the other. So treatment 4 over here, there is a, they call it a high waist. So you've got the mean here is quite a bit lower than the median. So that median is way up high relative to where the mean is. So that tells us that there's a low value that's really pulling everything down. It's pulling that mean down, but the median isn't quite as influenced by one extreme value either way. So that mean ends up kind of tanking lower because we have, in this case, there's a 0 here that kind of pulls everything down. So that shows that we're kind of negatively skewed towards the lower values because that means coming down. Whereas something here like treatment 3, we're pretty consistent. They're pretty close together. Again, maybe pulled up just a little bit because of that outlier, but not nearly as much as treatment 4. So we can kind of just get a sense of kind of visualizing the distribution of each of these treatments. The height of the box is really a good way to compare the amount of variance in that treatment. So just being able to compare the different treatments, 2 definitely looks like it kind of had the most variation within it, whereas treatment 3 was the most consistent. Kind of ironically, other than that outlier there. So that's another visualization. We'll talk about in next week's session the assumptions of our analysis that we're going to do, and one of them that we do care a fair amount about is how consistent the treatment variances are, because we do an analysis of variance, and so that ends up being a pretty big one that we care about. That hopefully the treatment variability is similar between the treatments. So that's kind of a big one for us to take a look at. And this is the Box-Whisker is a real nice just visualization of that, just the magnitude of those variances and if we'd expect to be concerned at all. And it might be close, maybe not. We'll kind of get to know that next week, perhaps when we run into the data here. So those are kind of the big items for us on the Box-Whisker. There are options. This is the typical graphing function within ARM. So we can, of course, do a few different things here. I won't really belabor the point and dive into all of the different options right now. But we have done graphing webinars before where you can check out the help topic to see some of the other things. But really the biggest ones end up being right on this page, and kind of why we pull them out. The x-axis as labels is really nice because otherwise you have the long treatment name and description. It just kind of makes it hard to actually see what we're looking at. So I really like to have that on because that pulls those labels to the right, giving us a little bit more space to actually look at the graph itself. And then we're also displaying the data values. So those small little red dots are the individual data points. If I turn that off, then I don't have to see them, but it's kind of just nice to kind of get that X-ray vision, if you will, kind of what went into making these boxes and whiskers. And I guess if we were talking through our story problem here with reviewing the data, we do have that plot 705 kind of marked as an outlier. And as we mentioned before, doesn't mean we should just immediately throw out 705 and not care at all, but definitely would be worth looking at. So we can go back here to that 705. And just numerically, it doesn't really stand out. It didn't really stand out on that assessment map, but just in terms of how treatment 3 had shaped out. So here our 705 really doesn't stand out at all spatially. But if we do click on treatment 3, we can see that in all the other reps, treatment 3 was pretty good at controlling, and it just really struggled in this replicate. So it would be worth just taking a second look. If we can walk right over to plot 705, that's really the best route. We can feel confident then in this 25. And if that really is the case, we have the opportunity here on the right. There is a comment, so we can put in any text that we might want to note, that we double checked. This is 25, even if the Box-Whisker thinks it's an outlier, or some sort of note like that. You could even take an assessment photo. If you're out there with ARM Mobile, it just pops open the camera and you just snap a picture of the plot, or whatever plant that you're looking at, to kind of provide some nice documentation. So that way later on, someone in the office doing data summaries takes a look and is concerned about that value. Well, no, we can say, hey, we already checked it out. It's good. Because again, unusual data doesn't just mean it's unusable. We should just blindly throw it out. It really is important to kind of think critically if this is not indicative of what the treatment really did, or if it just by chance was something unusual that occurred. All right, so those two tools over here in the properties panel, the Box-Whisker and the assessment map, those are really the top ones for getting a good look at the data, just to understand what we've got and to make sure that anything extreme, high or low, we ended up in this case, everything ended up kind of on the high end for unusual values, but certainly could be the other way around, depending on your assessment. But there are a couple of other functions that might be useful in some cases. So I'm going to unpin my properties panel and show the column diagnostics. And we're actually going to spend a lot of time with this tool next session. Let me move some of these panels around. So we won't go into everything that's on this panel right now, because a lot of it is geared towards data review. But I do want to point out that kind of on this top first table with diagnostics, there's a few kind of summary stats, if you will, that kind of your stat sheet from baseball or something that can give us an overview of those data points as well, if we still wanted to dig a little further. So there's just really simple things like N would be number of data points. Okay, we've got 50 data points in this assessment, only 10 unique values. So we had a lot of times where we used the same number, which in this case, not super surprising. We're just estimating the percent area of coverage. So we were inherently kind of limited to rounding to the nearest 5. So that's not shocking. 50 is the number analyzed. So that would be if we ended up throwing out a data point. And in this case, we did correct that 120. So there's a couple of those potential issues we still kept in, so we don't have any that are thrown out. But if we were to, I'm just going to take this 25 and change it a little bit for us just to get an example that if that was missing, then you'll see we end up with only a 49. That's how many data points are actually being analyzed. And then the next columns kind of explain why something isn't being analyzed. And so we had one plot that was just missing. Empty would be if I didn't use the missing data point. So this period is really the best way in ARM to mark down that I just don't have a value for this assessment. If it's left blank, that can be a little confusing potentially to someone else looking at this. Is it supposed to be blank because there was no assessment, or was it left empty on accident? And the there actually should be something here. So in general, it would be preferred to put in a period to kind of mark that intent. I don't have anything to put here. There's nothing to see. Putting that period makes it clear to everyone that there's nothing here. So that's the difference between missing and empty. I'm just clicking from this column back just to have this page refresh when I make a change. And then damaged, if we had used that damage marker to cross out an item, that'd be another reason that that number would shrink as to how many things we're analyzing. Then there's minimum rep and maximum rep. So since we're missing a data point, one of the replicates has only 9 values in it, whereas all the rest of them have the 10 values that we'd expect. And we've got the 5 treatments. Then these rest of these calculations we will deal with later in the data review. But another reason to come here is there is an outlier calculation here on the diagnostics panel. Almost always, you probably won't see the panel actually. So if you have an assessment that does not have any values that constitute an outlier, then this panel just isn't visible. So if you don't see, now I've got diagnostics, recommendations, and outliers. The vast majority of the time, you'll only see the 2 sections. But if this section pops up, then that means there's a plot, and here I clicked on it to take us to plot 203, has been identified as an outlier. So the calculation here on the diagnostics is different than the one used in the Box-Whisker. So I think the Box-Whisker, if I recall, we had one value that was an outlier, but it wasn't 203. It was a different one. So there's kind of a few different ways to try to calculate and come up with what could be an extreme value. And the Box-Whisker was really looking kind of treatment by treatment, if a value is too extreme one way or the other relative to the rest of the values just within that treatment. What we have here in the diagnostics is a little more statistically rigorous as to the calculations behind it, at least. And I'll admit I don't know all of the theory behind it, but I know that it uses this max standard residual value. And the idea for it is that it's very conservative in that it's quite a surprise to end up with an outlier. It's very rare actually to have an outlier pop up in this calculation. It's really designed that if you see one here, it is probably quite legitimate. And there's that standard residual value here that's 3.5 rounded here at 3.472 if we want to get technical. That calculation there has really highlighted this plot 203. So that would be definitely a quote unquote cause for concern if an outlier pops up. As you can about guess, we've kind of jerry-rigged this example to be extreme. But as I said, in the vast majority of cases, you won't see this outlier section here because it's very rare to get an outlier. And I think I had to work, I actually had to work pretty hard to just make up the data example to get an outlier. It's hard to even fake it because this calculation is just kind of that way. And I wanted to point that out because there's actually one other section on the column properties panel, which has kind of a lot of the older data review functions there. There's this whole fix functionality and stuff on the column properties. That's really kind of an older, the older statistical methods of data review. And we'll talk about that next week. But it does have an outliers calculation here that unfortunately is also different. So there's a variety of different ways and formulas, if you will, for trying to spot outliers. So at the bottom of the column properties, there's this outlier tool, and you can pick which method for finding an outlier. So let me close this diagnostics just so we have kind of one thing that we're clicking on at one time. So at the bottom here, if I click on Box-Whisker and press Find Next, it will move my cursor. I think I was already happened to click on it. It'll move my cursor to the next plot that is considered an outlier. So that was plot 203, which actually I think was the one that column diagnostics had. So I think we're getting a pretty good case that this value is unusual. But just to point out the other ones, so there are two other calculations, ways to try to identify an outlier. And this would be based on the grand mean and your standard deviation within the assessment. So you can go any values outside, plus or minus 2 standard deviations from the grand mean in this column can be, would be identified as an outlier, or maybe a little more strict of a requirement would be if it's outside of 3 standard deviations from the grand mean. And you would just select which option you want and then press Find Next. And you'll see that it scrolls again, it continues. We've really only got that one. I bet though, if I loosen the restriction up, we'll maybe find another one. There we go. So here we've scrolled again to plot 801. So this 40 is a little extreme as well. And if I just keep pressing Find Next, I've really toggled between just those two. So these outlier calculations, just because it tells you it's an outlier doesn't mean let's mark it as damaged and move on. We really kind of want to think about what it might be telling us. Because in theory, if you remember whatever statistics course you've maybe taken in the past, or maybe in the way distant past, if you had even a perfectly normally distributed data set, and maybe it's got 100 data points in it, even totally perfectly normal bell-shaped curve, you would still have, was it two data points? Is it like 2.5% is outside of the 3 standard deviations? And then is it like 4 or 5% that would be outside of 2 standard deviations? So even in a totally perfect normal bell-shaped curve, you would have a couple of values. If you have a lot of assessment values, you would have a few that just naturally, the way things are, would be outside of that number of standard deviations. So you don't want to just blindly throw anything out that gets highlighted in any of these tools. But that is the one way that I've kind of understood the outliers calculation here on the column diagnostics, and why it's so conservative is it does take into account how many values we have here. So it does do a better job of, just like I said, if you've got 100 values, if you're just looking at the standard deviation, there's going to be a couple that just happen to be out on the way edge of the tails. So that's why this is really more conservative and really highlights pretty well that we should actually care about this plot 203, that this value is pretty unusual. So I guess to put a bow maybe on that, certainly it seems like we've found that this value is concerning a little bit. In that perfect world, like we said, if we're out in the field, I can go right back to review our assessment. We could make sure that we typed it in right. And if it definitely was, maybe we've noticed something a little unusual, and we can add some documentation over here on the properties panel to make a note of what happened here at that plot. Take a photo for documentation. And now, or maybe later, if we did decide that this really is an exceptional occurrence that doesn't really describe what typically would happen with our treatment, we've got that damaged marker where we could throw out the value. But it might be good if you have a statistician at your disposal to really understand within the scope of your experiment, within the scope of your assessment, what is truly good grounds for removal of data points. Because as we said, we don't want to do that if we can help it. Every time we throw something out, we're losing power when we go to make an analysis later on, and we'll have less ability to definitively say we've seen these differences in treatments and their significance. So that's ultimately our goal here, is to feel really confident that the assessment as we've entered it in the program is accurate, and we've identified any extreme values that really aren't indicative of what really should or typically would happen with that product. All right, well, I've really made it through the list of all of the tools here for the data confirmation. Actually wasn't too long-winded, kind of amazingly. We've got a couple minutes if there are any questions. Otherwise, hopefully most of you will join us next week as well, as we kind of just continue on this track of now really starting to think about our analysis and specifically the assumptions. And we'll prepare this data set for the analysis by talking about what the AOV does and what we have to care about before we actually see the statistics, which will be our third session. So 2 weeks from today, where we'll actually run the analysis, see what we've got, and talk about all of the different reporting options and common questions and stuff that we get this time of year on kind of how to make the reporting go as smooth as possible. All right, well, seeing no more questions, I guess we can let you off with a couple extra minutes. So I appreciate everyone joining. Yes, to answer a quick question about the Zoom links. If you registered for all three, they were all each kind of separate on your Zoom to join. So it will be a different link than today's. So if you don't have links for the other two, then maybe shoot us an email. If you did register for all three, they should have all landed on there. Okay, so if your hyperlinks didn't work, yeah, if you wouldn't mind just sending us an email, make sure we can follow up with you. Yeah, that was one difference we did this year. Instead of having that attachment, because I was kind of worried that would land in people's spam folders. But yeah, that's helpful to know if the hyperlink isn't working. We can help you out and just get you that file. So, all right, well, thank you, everybody.
Thank you, Matt. Bye.
Yes, thank you. Goodbye.
Thank you.
Thank you. Goodbye.